We've introduced the BGG category O of modules of a semisimple Lie algebra G. These modules essentially have some highest weights, and their weight spaces can be thought of roughly as having this form. Now, we'll list a few properties, namely that O is Noetherian as well as Artinian. So this means that the modules have no infinite ascending or descending chains where one module sits inside another, etc. These chains end. Moreover, the dimension of the homomorphisms from one module to another is also finite. And the composition series, where the quotients of the modules in the composition series are simple, exists. First of all, it exists, it's not unique, but the simple modules, which are the quotients of the consecutive embeddings of modules inside each other, so the simple quotients, have unique multiplicity, so independent of the composition series. And this multiplicity will be noted M L lambda, where L lambda is the simple module, as we've seen before. Length of the composition series is called length of M, or Jordan-Holder length. That's the length of the composition series. And so a very simple example is, for instance, M of minus rho minus half the sum of the roots. So there, since minus rho is in its own linkage class, because the dotted product shifts first by rho, and then the dotted while product, well, the while element acting on 0 just gives 0 again. So M of minus rho is automatically simple and has a very simple composition series. So this is a very trivial example, of course. Then we can define the Grothendieck group of the category O, which is just, which consists of all classes M with integer coefficients, and we look at M with integer coefficients, the set of M with integer coefficients modulo B minus a C, where we have, if we have a short exact sequence, A, B, C. So if we have such a short exact sequence of modules, then we mod out by this difference, and this set with the plus operation, that's the Grothendieck group of the category O. Now, because we have these composition series, we can define the socle of M, socle of a module. That is the largest semisimple submodule. Then we have the radical of M. So that is defined such that it's the smallest submodule, such that M divided by the radical of M is semisimple. And then when this is semisimple, well, this is always semisimple, and it is called the head of M. So a few examples. If we have a Fermat module, M of lambda, then the radical of M of lambda was this largest submodule, N of lambda, and the head of m lambda will just be L of lambda, the simple module with highest weight lambda. So the first structural property of the full category is that it is the direct sum over characters of subcategories associated to those characters. And they contain modules, which are defined as follows, such that if you have an element of this module, then you take an element of the center minus its character, then some finite power of it, which may depend on the central element, will annihilate all vectors of the module, where z is an element of the center of the Lie algebra. So this says that a central character may jump around between different vectors which have the same weight, etc. But it will only do this a finite number of times, and the Jordan form will be basically diagonalized with a given diagonal eigenvalue. But there may be some parts which are off diagonal. But then this vector space is finite dimensional, and therefore a finite power will give 0. So we can actually say more for integral weights, which were gathered in a set lambda. We have that O chi lambda is a block of O. Now, what is a block? Block, two modules M1 and M2 are said to be in the same block if there exists short exact sequences such that M1 and M2 fit in those exact sequences in any order. This sequence needs to be non-split, and then moreover, if we have a sequence where M is M1, well, say M tilde is M1, and M1 is in the same block as M2, the same block as M3, etc., which is in the same block as Mn, let's call L tilde, then we set M tilde and N tilde also in the same block. The block of the weight 0 we will call the principal block, and it will play a special role. So these are the first structural properties of the category O. Many more are to follow.